After giving you the brief introduction about the gyratory compacting equipment, now next step, gyratory compaction level. That how many levels we should have to be familiar on our specimen. So here I would like to tell you there are 3 compaction levels. These are represented by N initial, second Ndes, third one Nmax. Actually this N capital, it is the number, Ini initial, it is the number, it is the design, N is the number, max is the maximum. So I will explain these 3 in just brief way, that where we are using this one, where we are using this one, and where we are using this one. So let me first of all tell you initial number. Of gyration. N initial. So here I would like to tell you, when the specimen is under compaction, it is going to increase the density of the material. So that's why it is a measure of compactability of the mix. At which level? So here I would like to tell you, it is a measure of compactability of the mix of mix, and based on density, compaction density obtained behind the screed before compaction. Let me explain this word to you. That what does it mean? First thing, as I told you, the Nini, whatsoever its value, it is going to measure the compactability of the mix. And after that, it is going to give us the density of compaction behind the screen. This is related to the field. This initially is related to the field. When paver is going, whatsoever this mat of the material is behind the paver, it is going to show some sort of the compaction, and that's some description of the compaction is related to the Nini. That's why before compaction the word is written over here, and its value range from 89 to 91% of GMM, depending upon the traffic level. That's it. So we will measure the density of compaction before the compaction, and how we are going to show in the laboratory, because actually we are discussing what is going to be done or what has been done or what we will do in the laboratory. So how we will say that our specimen has reached to this compaction level as it should be before compaction, and how much should be the number of gyration, I will show you and I will write down and I will explain to you at the end of this lecture. After this, design. Ndes. Design number of gyration. Here I would like to tell you one thing. This is my requirement. My requirement in the lab is end design. On the basis of this end design, we have to proceed further. So we can say that it is the number of gyration required for the specimen to reach the target density. It is the number of gyration required by the specimen to reach the target density. And also from here I would like to tell you that although we have written over here to reach the target density, but from this target density we should have to know this one, that this density is related to the life of the road. So when we say related to the life of the road, so here we can say that when should be in the field? It is in the middle of the service life of the road. Now, as in Nini, we had specified this value. Now, what should be the value of this one? So, its answer is Ashto M323. This is the name of this standard, or this is the name of this specification. Gives its value as 96% of GMM. 96% of this GMM. So here I would like to one thing. Here we can say that this design compaction actually shows us that during our completion of our compaction stage, we can see that we have attained our density. Although it's not that we will reach accurately to the 96%, it will be in the less than the 96%. But here we will say we are going to reach near to this density when our construction work has been completed. So here, let me tell you again, actually this compaction shows that when our construction work has been completed, there we can say that this design compaction has reached to the required level of compaction. After this, our last compaction level known as maximum number of gyration MEX. What's the meaning of this one? Here I would like to tell you, this Nmax is the maximum number of gyration where we can say that the specimen has reached to highest level of compaction after the completion of its service life. Here, just briefly, it is related to the compactability at the end of service life by the traffic load further compaction has occurred. Let me tell you what is the meaning of this one. You know, when we say at the end of the service life, for example, I have designed one road, I have constructed the road, and I have laid the asphalt surface, and in the initial stage, we have some certain level of the compaction. Now, under the traffic, under the heavier traffic, and under the weather condition, further densification is occurring. Due to this further densification, it is occurring because of the traffic load. Okay? Further compaction has occurred. So this further compaction has occurred is represented by this number, and its value is set at 98% of GML. And this maximum number of gyration, how much should be when we will perform in the laboratory, this I will show you in my next lecture. Thank you for seeing this.